So here we have another related rates problem. So we've got a balloon that is released 150 feet away from the observer. Balloon goes straight up at a rate of 8 feet per second, not too slow. How fast is the distance between the observer and the balloon changing? Okay, when I see changing, I'm thinking derivative with respect to time. When the balloon is 50 feet high, okay? So first thing I want to do is I want to draw a picture of this scenario to try to make life a little bit easier. Okay, so we've got a person, an observer, right? And there is a balloon that is released 150 feet away from the person. So here's a balloon over here, here's your person, a distance of 150 feet between. Now, when the balloon is released, it goes straight up at a rate of 8 feet per second. Okay? Now, the question becomes, how fast is the distance between the observer and the balloon changing when the height is at exactly 50 feet? So h is my height here. That's how high the balloon is. And z is what I'm going to call that distance between the observer and the balloon. Okay, number one, I want to know what they want. Okay, how or find, whatever, that tells me whatever comes next is what I'm looking for. So how fast is the distance between the observer and the balloon changing? So the distance between the observer and the balloon is changing as the balloon, okay, as the balloon changes heights. You can see the distance just gets higher and higher and higher and faster, right? So it just keeps going up and up and up and up. All right, now, what does that represent? Well, it's the derivative of that distance with respect to time, dz dt. That's what we're looking for. Now I need to write down everything that I know. So I need to look at the problem, okay? What do I know? Well, first off, I know that the balloon is 150 feet away from the observer. So the horizontal distance is 150 feet, okay? The next thing that I know, the balloon goes straight up at a rate of 8 feet per second. So the height is changing with respect to time, okay, of 8 feet per second. All right, dh dt is feet per second units. Your derivative is a rate. That's why it's called related rates, right? Now, why is the number positive and not negative? Because the height is increasing. Okay, the height, as the balloon goes up, the height gets bigger and bigger. So my derivative is increasing. Okay, therefore, if I have an increasing height, then my derivative is positive. If I have a decreasing height, like instead of being like a balloon, maybe it's like a lead balloon, right? That sucker's going to drop to the ground. Okay, so that would be a negative derivative. All right, what else do I know? So I've got these two things. I guess I also know this right here. The height h at 50 feet, I want to know at that moment when the balloon is 50 feet high, how is the distance changing at that exact moment? That's why we need calculus, okay? So how do I relate all of these through an equation? All right, I have what type of triangle? It's a right triangle. I know all three sides. How are all those related? You should be thinking Pythagorean theorem, okay? The Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So I have 150 squared plus h squared equals z squared. This is my equation that relates the variables that I have, okay? So now I need to take the derivative with respect to t. The derivative of a constant is 0. The derivative of something squared is 2 times something raised to the 1 times the derivative of the something, dh dt. Okay, this is equal to something squared, same thing. 2 times something raised to the 1 times dz dt, right? Okay, so now what am I doing? Well, I want to plug in everything that I know. So take in what I know from this part right here. Well, h is equal to 50, okay? So I plug in 50 feet here. And then dh dt is 8 feet per second. So I'm going to plug in 8 for this part here, 8 feet per second. And then z at this exact moment, ooh, I don't know what z is. I wish there was a way to figure this out. How in the world are we going to figure out what z is? Because look, at the end of the day, we're trying to get dz dt, right? Well, how do I know what z is if I don't know what h is? Well, wait a second. I know what h is. H is equal to 50 at the time we're looking for, right? So if I know both legs of the triangle, can I get the c? Absolutely I can. I just need to use Pythagorean theorem. So if h is 50, then that tells me that I have 150 squared a squared plus b squared equals c squared. Now, I'm not looking for z squared, the distance squared. I'm looking for z. So I'm going to replace h with 50. So I have 150 squared plus 50 squared equals z squared. And how do I get z by itself? I'm going to square root both sides. And once I square root both sides, type this in your calculator, you're going to get roughly 158.11. However many decimals you're required to round to, that's what you need to round to. Okay, so I plug this in here, multiply everything out, and we're going to get some magic here. Look, 2 times 50 times 8. Oh my goodness. Well, let's do this. 8 times 50 is 400 times 2 is 800, right? So that's 800 feet squared over seconds that way. And then I have equals 2 times 158.11 dz dt, right? dz dt. Okay, if I divide both sides by 2 times 158.11, I'm going to get a number, okay? Now, this is feet in here, so one of those feet cancels with the feet there. Okay, so one of those feet cancel. And so that's good that I get feet over seconds because it's a derivative. So what's this get me? This gets me 2.53 feet per second. Okay? So it's great that we got a solution, but we need to interpret our answer in the context of the problem. Okay, so how do we interpret dz dt equals 2.53 feet per second? You're not going to, somebody ask you, okay, how's the distance changing between you and the balloon? And you say, well, according to my calculations, dz dt is 2.53 feet per second. They're going to be like, what? What the heck is z, right? So here's it in English for you. Thus, the distance between the observer and the balloon is increasing. How do we know it's increasing? The derivative is positive by what? 2.53 feet per second. I don't just put it like that. I say per second. When the balloon is where? When the balloon is 50 feet high. Okay?